called a simple fold, right? There. And a simple fold in general, what is a simple fold? So a simple fold is a fold, it's just a fold that makes it easy. Right? But it might not be that, but a proper way to say it, this is like a proper way to say it. And the proper way to say it is it's a crease that makes it easy to fold. That makes it easy to fold. So that's kind of the proper way we might say fold, simple fold, meaning it is a crease that makes it easy to fold. Okay? Now let me generalize that with a result. Okay? So let me generalize it. So I can do a generalization of this theorem. And a generalization for this might be, let's look at an example. Let's look at this. I haven't made anything up, but this is what I've tried to make. So let's split this. So when you split into triangles, you can split into this triangle, this triangle, this triangle. That will give you 3 triangles. Now, can you fold it easy? So these are the lines. So draw these lines here. When you fold them, so let's take this, and when I fold it like this, there's a fold. Yeah, so it folds like that. So you have a crease pattern, and you have to try to fold it. So that's how you fold it. But there's one caution that I need you to understand here with the concept of a simple fold. And one caution that you need to be aware of is that whenever you're folding something, make sure your lines are touched up. So meaning when you fold this, the lines have to match up all the time when you fold. The lines match up as you're folding. And what I mean by that is that no matter what origami model you're doing, let's say you're folding a pinwheel, make sure your lines have to match up the same. So here, let me show you on there. So I just have to match up with the lines here. You see that? So this is how I'm going to do it. Right? That's kind of going back to what I would say in general. But now you have to see that piece of paper. So I get triangles all over the place. So this is called, do you know what this is called? It's called fold and cut. Fold and cut. So let me do this. This is the activity. So here I have this. Now I have to make it. Now you can do it in a different way, however you want it. So here I fold it like this. But now I can cut the slots here. So I can cut this slot right here. I cut that slot right here. That's going to give you a 1 fold to make it easy. So, yet again, this is not a very, very simple exercise, but try to do that at home if you can. So at any rate, this is not kind of a thing, but there's one application of a simple fold called a single vertex crease pattern. So I'll give you an application, and that's called a single vertex crease pattern. So what is a single vertex crease pattern? Well, a single vertex crease pattern says, let's say you have a circle, and let's say I give you 4 angles. Like, let me draw this because I've drawn that before. I've drawn 4 angles. Now, each of the angles add up to 360 degrees. Now, that's called a single vertex. Well, what is a single vertex? Meaning 1 vertex in a crease pattern. So how do you fold a 1 vertex crease pattern in an origami? We'll talk about that more later, but let's get on with the work. Remember what we said for simple folds? It's a crease that makes it easy to fold. So I should say this. I should say it is a crease pattern. that makes it very easy to fold. But it can be a bunch of creases. So a crease pattern might be a bunch of creases. So it is the crease pattern that makes it easy to fold. Well, that's kind of it. A single vertex, if you think about a simple fold. Remember our geometric objects. Like here, linkages are just what? They're just lines, right? So they're just lines. This is one-dimensional. Right? So this is one-dimensional always. But you can think about linkages as lines, as one-dimensional. Make sure you're trying to get this right here. Right? But then there's also the concept of what? There's the concept of polyhedras, right? So polyhedras. So a polyhedra, what is a polyhedra? Well, a polyhedra is a three-dimensional shape. So it might be a solid shape. So this is three-dimensional. So there might be that, but you have to think about it. And another example might be a piece of paper. So this is a piece of paper. It's two-dimensional. Now, if it's two-dimensional, this is a plane shape. So this is a plane shape right here. So this is called, do you know what this is called? This is paper. Right? And this is what? A flat. It's a flat figure. Or just a plane. However you want to say it. Which is two-dimensional. With me so far? Right. So now you're going to see what's happening right there. But now, let's do one more exercise and then I'll close today's lesson just by kind of a little remark that I want to make. Oh, 1, 9, 4, 5. So, let me generalize again. But it's kind of the main statement of the theorem. But now, I want to see how it goes. Okay. With me? Okay. So, now what I want to do is I want to talk about how to practice folding with origami papers. So, how to practice folding with an origami paper. And that's the question that we're going to be using a lot. But how do we practice this? Well, what is an origami first? What is origami meaning? Origami in general means it can be either mountain or valley, doesn't matter. So on one side, so I'll say this, on one side what you have is you have kind of a colored side, I suppose. And on the other side, you have a white side. Now, I'm asking the question, how is it different from both sides of the colors? So in a paper you have, let's say this is green on that side. Let's say this is green on the other side. Let's prove this. So I'll do a little proof here. This is what we're going to be doing. And I'll give you a little note here. This is not a subtlety, but you have to remember. If we have on one side to be what? Let's say the color is green or red. I like red. So. And what's on the other side? Let's say that this is also green. Then it's not origami, that means. So this is not origami. This is not origami. For this to be origami, you have to have a colored side and the white side. Let me explain what this means. Just as a kind of a generalization here, because that's not what we're going to do, but I'm going to state it right in the theorem. So here it is. So I think we're good with simple folds, the definition of what a simple fold is. But now, let me see that you're all paying attention. Right? Now, let me talk about, what did I just say before? Let's talk about where this comes from here. Sorry, this one. Let's focus on this. I'll put a little asterisk here, right? So with the colored side and the white side, right here. Let's explain why this is. Some people would be using this one, and I'll show you why this is not a correct answer. Okay. So now we're going to talk about origami, where you have a colored side. This is artist. This is computer science. This is mathematics all around, and white side. Now I carefully worked this out, maybe just as a proof here, but now you have to see what's happening. We have the colored side and you have the white side. Now what does this have to do? It's confusing to think about which ones are mountains and valleys. Well, you can label those if you want. So you can put an M and you can put a V. Sometimes it might be confusing. So I'll call this one mountains, and I'll call this one valleys. And the reason I call mountains and valleys so that I don't get confused on which one. Here I have a white sheer paper. Here I have a colored side here, and here I have a white side here. What's happening? So that I can distinguish which one. So I don't distinguish between both. Sometimes it might be confusing can I do this side or can I do that side? So many people get confused on which one to do. And that's why I said to get an origami piece of paper. I don't have that in my house. But this is how you're going to do it. So let me show you an illustration. Maybe something like this. So it's not kind of what I would see here. Let's say this is your colored side. I'm talking about it in just as a paper. Just as a paper. Not just as a two-way paper. Just as a one-way paper. Right? So just call that one-way paper. So what does this have to do with? So you have to see which ones you're doing. Now, first, I let people choose the color side because it's way easy. Because you can see the color. On the white side, you do after. So once you've done the color side, then the colored after the white. Colored after white. The reason I want you to do the colored one is because it's so easy. Some people can distinguish which one is it. Which one do you fold? Do you fold this side or do you fold that side? And I guess that do the color side first, then do the white side, which is very, very easy. Now, just to close this out, because I'm not going to talk too much about this, is that let's talk about something with a white side and a white side. Right? Sometimes it's confusing. So it is confusing always. And I will make it very travelable. Let's say you're folding in a pinwheel. That means that when you fold the white side and the white side, then it doesn't fold. It doesn't fold properly because it doesn't distinguish which one you're folding. So that's why I told you get an origami piece of paper with the color side and the white side so that it makes it easy. And always. And make sure you cut it into square. So I'll talk about that step in just a bit more. So let me write this down here. Let me just put it on the top because I'm going to need all of this. So let me talk about the famous concept that you always have to cut into square. So when you do origami like this, always cut into a square. When you're folding these kind of things. Now, if you don't cut into a square, if you don't have scissors in your house, maybe you can use a ruler. So I'll show you what I get. You can use a ruler and you can tear this out here. You can see that? You just have to tear it out. Right? One more moment for this is that you always have to cut it into a square. The reason you need to cut it into a square so that it makes your best fit for your model. So it creates